Okay, so in this question, Caroline is starting on a diving board from the top of above a pool, and up at the top here she's not moving. So up here she's not moving, and she therefore has 100% gravitational potential energy. As she starts to fall, she's converting GPE, gravitational potential energy, is being converted into kinetic energy. So here she's got more kinetic energy and less GPE as she gets closer and closer to the pool. And at point D, where she's actually just reaching the pool here, she's going to have 100% kinetic energy for her perfect dive. So why does Caroline have no kinetic energy at A? Because she is not moving. Okay, and then if we look at the chart here, we can see the total amount of energy is 8, and that's 8 gravitational potential, and because she's not moving, 0 kinetic, then it's still 8. Remember, energy cannot be destroyed or created, so we can't have lost any energy anywhere. So you've got 7 now gravitational potential because she's closer to the Earth, and the other 1 is in her kinetic energy. It's been converted. Again, that's not going to change. It's going to be 8. Now her GPE and her KE are equal. Finally, at point D, she's got total energy 8, and so 0 gravitational potential energy, which means she must have 8 kinetic energy. So that's the first part of the question done. There's no loss of energy to air. That's because the KE and the GPE add up to equal total. If there was losses to the air, we would be seeing total energy be 8, and we would see GPE at the beginning would be 8, and kinetic energy would be 0. Okay, and then at stage B, we would have kinetic potential energy, maybe that would be 6, kinetic energy would be 1, and then we would have perhaps heat energy, thermal energy, would also be 1 as she's moving through the air, and as there's friction happening between her and the particles, we would expect to see that. So GPE, KE, so then we've got thermal would equal 1, so that the total of all the energies, as we split them up, has to equal the total energy we've been told about, this energy here. So because that's not there, that's how we know that there's no loss of energy to the air. The name of the force that causes Caroline to speed up as she falls, it's called gravity, but we can also call that force weight. Now, she takes 0.5 seconds to move from A to B. That's quite a short distance. From C to D is a much longer distance, and she also only takes half a second, so she must be falling much faster here than here, because she covered more distance in the same amount of time. So she covered more distance in the same time. When Caroline enters the water, she slows down. Give the name of the force that slows her down. She's got friction from the water working against her. That's why when you jump into the pool, you're not going to get hurt, but if she jumped from that high of place onto concrete, she would get hurt because the air's got less of a friction. It's going to apply less force to her than the water would.